Welcome and thank you for joining us today for Cloud Network Traffic Data, empowering network and security operations in the hybrid multi-cloud era. My name is Raleigh Gould and I'll be moderating today's event. Our featured speaker is Shamus McGillicuddy, VP of Research covering network infrastructure and operations at Enterprise Management Associates. Shamus leads the infrastructure and operations practice at EMA. His research examines how IT organizations leverage network observability, network automation, AI-driven network management, and software-defined technologies. While Shamus will defer answering your questions until the conclusion of today's event, feel free to log them anytime by using the Q&A functionality. Also, today's event is being recorded, and you will receive a follow-up email from EMA that will include the on-demand playback as well as a link to this new research report. So I hope you'll check that email out. And now I'd like to go ahead and turn things over to our featured speaker, Shamus McGillicuddy. Shamus?
Thanks, Raleigh. Thank you, everyone, for joining us today. So this is independent market research into how enterprises leverage cloud network traffic data, sponsored by two vendors, BlueCat and NetScout, both known for working with packets. In particular, BlueCat, recent acquisition of Live Action Networks, is their avenue into the world of traffic data. And then NetScout, you're probably familiar with them. They are also very focused on traffic data. So they make this research financially as possible. They get access to the data, so forth, but they have no editorial input into the report itself. They don't see the report until I've written and published it. So they have, they see it about the same time you see it. Research goals and methodology. Why did I devote a whole research report to cloud network traffic data? A theme that has been echoed over and over again in my ongoing research. I've been running the network infrastructure and operations practice at EMA for about 10.5 years now. And for most of that time, the cloud has been challenging to network observability or network monitoring, network visibility, depending on what year it was. Network observability is a term that is only maybe 5 or 6 years old. But yeah, previous EMA research on hybrid and multi-cloud networking strategies and cloud networking operations have consistently found that enterprise IT organizations have problems with network monitoring, network operations, network observability when they see services migrating to the public cloud. And research that I did earlier this year, sourced in the fine print below, Enterprise Strategies for Hybrid Multi-Cloud Networks, that was published in April and was a refresh research I did in 2023 and 2021, found that only 29% of people responsible for or involved in cloud networking strategy were completely satisfied with their cloud network observability capabilities. One of the reasons for this is that a lot of network monitoring, network observability tools were born in the on-premises network. They were designed to monitor things over which you had administrative access and control. Once you move to the cloud, you don't really have that. Everything's, the cloud providers own the hardware and they're providing abstracted infrastructure services to you, and your ability to instrument and extract data from that environment is curtailed to some extent. Things have improved over the years, but we also see that the teams that really kind of take the lead and own cloud strategy, like cloud teams and DevOps teams, they don't necessarily always understand or focus on the value of network traffic as a key piece of operational tooling and visibility and observability. They tend to be focused on so-called melt data, the metrics, logs, traces that they extract from the application environment, don't necessarily extend that visibility to the traffic. So they're really focused, when they're focused on observability, they're usually focused on understanding the application environment, but not necessarily able to get a good understanding of what's happening with traffic. And traffic determines experience. It may not determine application performance always, but it definitely determines experience. And the network team often gets pulled into troubleshooting issues when experience is exposed as a problem. The research that I cited from April also it found that IT and security teams want to augment cloud observability with traffic data. 49% said that network flow data is critical in the cloud environments that they are working in, and 38% said packet data is critical. Those are the two pillars of traffic data that NetOps and SecOps teams work with. So I wanted to do research that explores this problem. The goals were to explore the value of enhanced cloud network observability when you augment it with network traffic, going beyond melt to network traffic, and to identify the tools that organizations use to implement that. The methodology involved, we surveyed 250 North American enterprise IT and security personnel whose organizations were using at least one cloud provider today. Most of them were multi-cloud. They were enterprises, mid-sized and above, 1,000 or more employees at minimum. We captured 13 industries in the survey, and you see the 6 most prominent ones here. So financial sector, healthcare, manufacturing, two divisions of manufacturing, heavy manufacturing, and then consumer goods manufacturing, and then professional services not related to IT, so legal, accounting, things like that, and retail, wholesale and distribution as well. So why do you need to get serious about cloud network traffic? If you're here, you probably already know the answers to this, but I'm going to prove my thesis anyway. Cloud traffic data is becoming critical to NetOps and SecOps, not just in the cloud, but for total operations, end-to-end infrastructure and services. Networking teams and security teams don't focus 100% on the cloud. They're usually focusing on the end-to-end environment, and they usually have good traffic data for other parts of the network, but they don't necessarily have it in the cloud. So 90% of the respondents in this survey, they told me that they expect cloud traffic data to become more important to NetOps and SecOps over the next 2 years. And that includes both packets and flows. Both of those types of data were cited by 90% or more people. We also found that respondents who reported having effective methods for collecting and analyzing packets and flows in their cloud environments were able to resolve both security and performance issues faster. The way we determined that was first we asked them a question: how long does it usually take you to resolve a network performance issue in the cloud? And then we asked another question: how long does it usually take you to understand a security event or security incident in the cloud? And we cross-tabbed both of their responses by how effective do you feel you are at collecting and analyzing cloud traffic data. And the result was that they are faster when they're good at getting that data and analyzing it. So, hence, cloud traffic data is critical to NetOps and SecOps, I would argue. Our belief is that it augments melt data in a number of ways. The top benefits of collecting and analyzing cloud network traffic data effectively are listed on the left. So most of them are seeing a ton of benefits. Like 70% say when they are working well with cloud network traffic data, they are able to measurably reduce security risk. 62% say they're more operationally efficient. They spend less time collecting data, analyzing data, trying to understand the gaps in data. Like I talked to a network observability architect earlier this year, a Fortune 500 company. He told me that quite often the network operations team, well, what he often sees is there is an understanding that there's a problem with an application in their public cloud environment. The network operations team goes to their tools and can't find evidence of an issue. The DevOps and cloud team go to their tools and can't find evidence of an issue. All the tools are telling them that everything's fine, but it is not fine because the users are screaming at them. What happens then? The two teams spin their wheels, searching endlessly for problems that are not being revealed by their tools. That is a waste of time that could be solved by better tooling. And I would argue better access to an analysis of traffic would in the cloud would probably empower that NetOps team to pinpoint issues that the application observability, the DevOps observability teams are failing to find. That would drive operational efficiency, which 62% of the people in this survey say they are doing. It would also lead to faster detection and resolution of security incidents. If the security team has pinpoint visibility of what's happening from a traffic perspective, they are going to be able to detect anomalous and suspicious behavior if they have the traffic data that tells them who is communicating with what is being extracted, what's in the payloads of that traffic. It makes sense that 60% say they can detect and resolve issues faster. 58% said they're improving their compliance, like being able to demonstrate when you have, for instance, packets associated with cloud traffic, you have a record of what happened. You can, report, you can respond to an audit much more effectively and prove that things are as they are supposed to be. And then again, 52% say improved user and customer satisfaction. That scenario I told you where the NetOps team and the DevOps team both had tools telling them that everything was fine when users were complaining. That leads to poor satisfaction among users and customers. 52% say when we have good traffic data in the cloud, users and customers are more satisfied. And then a stretch opportunity here, 44% say that traffic data gives them an opportunity to optimize costs. There are a lot of ways you can imagine that happening. Like, if you have to correlate traffic data with, what you have in terms of workloads, for instance, you might identify that there's certain workloads in the cloud that never talk to anybody on the network, and that would indicate that it's probably an orphan workload. On the right, you see companies with best-in-class approaches to collecting data, people who've told us that they are more effective at collecting and analyzing cloud network traffic. They were more likely to cite operational efficiency and user and customer satisfaction as top benefits. So those are, if you take a best-in-class approach to working with cloud network traffic, you're definitely going to see bigger opportunities around operational efficiency and user satisfaction. And those are things you want to do because that's going to save you money, allow you to do more with less, which your CIO is already telling you to do, and it's going to drive happy customers, which is going to lead to things like more revenue, ultimately, customer retention, things like that, and also just more productivity inside the company. Unfortunately, cloud traffic data is hard to work with. Only half the people in our survey said they felt that they were completely effective at working with cloud network traffic. And we broke this into two things. What kinds of challenges do you have with working with packet data in the cloud, and what kinds of challenges do you have working with the VPC flow logs, which is the proprietary flow data that most providers produce, cloud providers produce for customers to use for managing their cloud networks. AWS VPC flow logs, Google VPC flow logs, whatever. So packet challenges, like more than half told us that they have concerns about security risk associated with capturing and storing data. How can we make sure that that data is encrypted when it's at rest and is encrypted when it's being mirrored to a tool, for instance. But then also encryption limits visibility because most traffic is encrypted these days, or increasing numbers of it are encrypted for legitimate and illegitimate reasons. And when it's encrypted, a lot of tooling have problems with getting full access to it. They can see the header information, but not the payload data, and that payload data is often important to analysis. Data quality issues. So they have tooling for accessing and analyzing packets associated with the cloud, and they're dropping packets. There are errors, conflicts between different tools, things like that, making it hard to sort of correlate across different tools. Data volume overwhelming tools. Packets can really pile up quickly. If you are trying to capture everything, it's going to overwhelm your tools, and also it's going to drive up costs, which is the last item there. 44% of people struggling with that. When it comes to VPC flow logs, which, as I mentioned, are usually proprietary and don't really, most networking security teams are used to working with standards like NetFlow and IPFix and SFlow, which have specific formatting that their tools are proficient at analyzing, collecting and analyzing. A lot of observability vendors on the networking and security side find they have to do a lot of work to support VPC flow logs due to proprietary formatting and other issues. The top issues that people are struggling with when it comes to VPC flow logs is integration issues, like integrating flow logs with your existing tools, for instance. Data volume overwhelming tools is a big concern. Latency, there's no real-time insights coming from these from VPC flow logs. It's all summarized information that's coming to you after something's actually happened. Siloed insights, that specifically is about the fact that if you're multi-cloud, the flow logs you're getting from your different cloud providers are not necessarily easy to correlate because they're both they're all proprietary, native to different cloud providers. And data is too complex to parse or enrich. So people just find it hard to work with this data. It's complex, much more complex than the standard formats they're used to working with in their traditional networks. So working with cloud network traffic, 58% of the people we surveyed, despite the fact that they see numerous challenges with it, they believe that cloud VPC flow logs are very useful. And 62% said it is very important for their traditional observability tools on the net, the NetOps team, the SecOps team, to be able to collect and analyze these flow logs. How do they want to use it? Number one, security monitoring. It's really useful for just seeing patterns, understanding who's talking to what, trying to identify anomalies, suspicious behavior. 66% say it's good for security incident analysis. They've detected a problem. Now they go to the VPC flow logs to see, where things went, to try to understand if there was exfiltration, things like that. 57% say it's really useful for troubleshooting network and application problems. And 56% say it's good for performance monitoring. So yeah, more than half, well over half, most of the people in the survey identified 4 use cases for it. Policy management, security policy management. Almost half said that was a useful way to consume and use these logs as well. So, for instance, using VPC flow logs to understand how everything is talking and using that to guide how you design security network policies in your cloud environment. Getting packet data. This is much more involved than VPC flow log, getting VPC flow logs. But first of all, 80% of the respondents in our survey told us that it is very important for them to have a consistent, unified approach collecting network packets across clouds and private networks. So what we have today, a lot of time, is people will tell us that they've got, they got packet capture capabilities in their data centers. Then they have completely different tooling, often native to, I got to close my window because a helicopter is apparently landing in my backyard. And then, yeah, so they have like traditional packet capture solutions in their data centers. And then they have 1, 2, 3 cloud providers, and they're using native packet mirroring tools in those environments, and maybe some native packet capture analysis capabilities that are different from what they're doing in the data center. Or, they've got like maybe they're using like open source software or something. But the bottom line is, when they want to understand what's happening across their hybrid multi-cloud network, they don't often have a tool that allows them to just search packet data across all those environments, identify duplicate data in different parts of the network. Like, it's just very complex to try to work with packet data that's coming from multiple different clouds and on-prem. And so what they're saying is, we need a unified approach to working with this data. We can't have silos of packets in each environment. People who told us that they had especially effective approaches to working with cloud network traffic we're much more likely to say that this is a very important priority for them. The tools that they're using today to get that traffic. Obviously, 69% said cloud provider traffic mirroring services. More and more cloud providers like AWS and Google, they offer a traffic mirroring service. So you can mirror packets from their environment into a tool of your choice. It's not as mature as like enterprise grade solutions you might use to mirror traffic off your data center networks, for instance, but it's gradually getting more mature over time. But yeah, that is like the quickest way to get packets out of your environment and then figure out how to capture them or analyze them from there. 67% say they are actually deploying packet capture software in the cloud. This might be open source or vendor provided. And then a slightly smaller number said they're actually streaming packet data from their clouds to on-premise packet capture appliances. And that was actually preferred by people who told us that they were more effective at working with cloud network traffic. So that was an interesting finding. I can imagine that gets expensive, so because of the fees that their cloud providers would charge for that. So they're probably being very selective with that. I would think it would be probably driven by compliance, which often drives budget. And then 45% said that they're using packet broker or network tap software deployed in the cloud. And that was also a potential best practices preferred by the more effective organizations in our research. And that software allows you to groom traffic, deduplicate it, enrich the data, so that when it's analyzed, you can get more insight out of it, but also your tools are more efficient working with packet data when you're using that type of tool. So what are the essential use cases for working with the cloud packet data? We already talked about what they're doing with VPC flow logs, but here you see most of them are doing a ton. Like 82% security incident investigations and response. So packet data plays a huge role in investigating security incidents. It's also playing a huge role in security incident detection. And then performance monitoring also, and performance network and application troubleshooting. But also, like, most of them are using it for compliance checks and for infrastructure optimization, like identifying how you can optimize how you designed your cloud networks by understanding, inefficiencies in traffic flowing over your cloud network, for instance. Like, oh, why are we hairpinning this and there, and like, maybe we should remove this bump in the virtual wire here, things like that. What are they doing to analyze cloud packets? So NDR is a huge thing. So very SecOps driven, 76%. So more than 3 out of 4 people in our survey say that cloud packets are driving network detection and response or security monitoring tooling in the cloud. But most of them are also doing, feeding this data to network performance management solutions, forensic packet analysis tools like Wireshark, for instance, which might be driven by a security use case or a networking use case, NetOps use case. And then 55% almost say application performance management. So those tools that tool set that the DevOps or cloud team are using, that's very Melt-centric, all about metrics, logs, and traces. Now it's about packets too. And then compliance monitoring and auditing is also a majority use case. And it's in blue because we found that people who have the more effective methods for collecting and analyzing cloud network traffic were more likely to select that one, which tells you that they're identifying that as a use case that they may not have been able to tackle before because they just didn't have good enough data quality or enough of data to actually use it for that. But once you have like good data quality and you have good data retention, then you have data to the extent that it can support something as exacting and demanding as compliance and audits. So key takeaways, cloud observability, as I mentioned, often is all about melt data, but 90% of the people in this survey told us that they feel that packets and flows will become more important to NetOps and SecOps over the next 2 years. Effective methods for collecting and analyzing cloud traffic data correlates with faster resolution of performance and security issues. It is in the data that when you've got traffic data readily available and of the quality and extent that you would want in your on-prem environment, you start to be able to return, accelerate mean time to response, mean time to insight, mean time to resolution. Only half of the organizations that we surveyed here have fully effective methods for working with this data. But they're clearly seeking to integrate cloud provider VPC flow logs into their observability solutions. And they're also very driven to unify the collection and analysis of packets across public and private infrastructure. The report, this webinar covered a subset of what's in the full report, which you can see the cover of it here. You can see the link to download it on the left. Get your copy today. May be available on the websites of some, if not all of our sponsors. I believe it is available on the websites of all of our sponsors. I don't know if they posted it yet, but I sent them copies of it to do so. Yeah, with that, I'm going to turn it over to Raleigh for questions.
Thanks, Shamus. The first one is, I am curious about cost optimization. One of the complaints I hear is that it costs a lot to get any network traffic data from the cloud. Any insight on how they match what cost savings they get?
So I didn't dive into like whether the cost, whether the cost of acquiring this data pays for itself by identifying optimization opportunities, but I would think it's possible. It depends on like how demanding your data requirements are and how you work with the data, how you store the data. I think it's important to be strategic and intelligent about just how much traffic data you're collecting from your cloud environments and where you store it and whether you extracted it on-prem or not. But I think I am also aware that there's just a lot of decentralization in the cloud. And there's a lot of inefficiently used resources in the cloud due to years of shadow adoption, decentralized adoption of technology, poor controls around decommissioning resources. And traffic data can, when you correlate it with inventory information, for instance, like if you're able to discover all the assets in your cloud with a good discovery tool, and then you're able to correlate that with traffic and identify assets that are doing nothing, or if you're able to identify pointless inefficient use of different types of software, different types of network designs, things like that that are driving up your costs. I think you could actually get to the point where the cost of getting this data pays for itself. And I'm not even touching on the cost of downtime and security incidents and regulatory violations, which all have dollar figures attached to them. If you are, EMA research currently puts the cost of downtime in around $13,000 or $14,000 per minute. So if you're having cloud outages that last like an hour or more, your costs go up pretty quickly. And if you can prove that the investments you make in cloud network traffic acquisition and analysis can drive down or eliminate lengthy downtimes, that is an opportunity in itself. I also know the cost of downtimes pegged in the millions of dollars per incident, depending on which research you look at. And you are probably fully aware of the types of, or someone in your organization is fully aware of the types of penalties you'll pay for a compliance violation or an SLA violation. If you have some customer-facing SLAs associated with your cloud environment, you can start to justify costs by reduced risk of those types of things pretty quickly. So, but yeah, I think it's very specific to individual organizations.
Thanks, Shamus. The next question is, do I actually need to capture packets in the cloud? Can I just analyze metadata?
Well, first of all, where are you extracting that metadata from? Like, because part of this research wasn't just about capturing packets, it is accessing packets. So yeah, a lot of people are still working with packets, even if they're not capturing them. They still need packet data to generate, to send streams of packets into specific tools that specialize in producing metadata from that traffic and from those packets, and then analyzing it either in real time or forensically. So still, there is a need to work with packet data, even if it is, being discarded after you've actually generated the metadata. But yeah, I will point out that 26% of the organizations in our research told us that they had continuous packet capture deployed in their clouds. And those people tended to report more success with how they work with cloud network traffic than those who only have manual packet capture in place that they trigger manually when they have detected an incident. So basically what we saw was people who are fully automated and continuously capturing packets in the cloud tend to have more success with working with cloud network traffic in general. People who have automated triggered packets captures in response to incidents or problems detected by their tooling are moderately successful, and those who are fully manually capturing packets only occasionally and mostly living in the metadata world are having the least amount of success with how they work with cloud traffic. So that's how the data bore it out. But yeah, that's my answer.
Great insights. Thanks, Shamus. The next question is, where does NetOps sit in the overall performance and security ecosystem these days when cloud is to the fore? For example, are they still in the front line in cloud environments, or is DevOps, SecOps taking the lead and pulling in the network team when needed?
I mean, the answer to this question is different in every conversation I have. So I can't really characterize it as a general thing, but I will tell you that I talk to lots of network engineers who are whose organizations are creating net DevOps capabilities in their organizations for a variety of reasons, one of which is to align with DevOps. That is part of that is driven by infrastructure as code strategy, but it's also about operations. You also, when I do research that looks at the collaboration between NetOps and SecOps teams, their collaboration is very often driven by three things. One, secure access service edge is forcing them to work together because it's a converged platform. Two, the cloud is a scary place, and both of them need to impose some control. And so they're building out guardrails for DevOps teams so that they stop breaking things. And then three, the biggest driver, or maybe the biggest driver of collaboration between networking and security is network data. The security team needs network data from the network team. And the network team is expert at providing it, whether it is in the data center, the enterprise network, or in the public cloud. And so data is sort of the currency, I think, that forces NetOps, SecOps, and DevOps teams to work together, because SecOps teams quite often lack the expertise around network data to extract it efficiently and meaningfully. DevOps teams don't even understand the value of network traffic quite often. And the NetOps team lives in traffic. They know packets from birth, like they grew up with Wireshark on their laptop. they understand flows, they understand metrics too, because they've been using SNMP to extract it from their infrastructure forever. And so the data, every group has its own approach to data. Like security teams really focused on hosts, network teams very focused on traffic, application and DevOps teams very focused on instrumentation, like data extracted from instrumentation of their application environments. And they're all living in these silos that don't really converge naturally, but are being forced to converge through research, through the trends that we see exposed in research like this and other research I've done, so that they all work together to deliver on use cases like security incident response, network observability of performance, and compliance and auditing and application experience. All of those things are questions that require whose answers lie in the convergence of three different sets of data from three separate groups. Now, and to close out my answer of this question that's all over the place, I'll also say that NetOps is still regaining its footing in the cloud. The question was asked in a way that suggested at some point NetOps had some control in the cloud, and they never did. Like the enterprises went in the cloud and thought the network team could be removed from the entire operation. The network team is in the way, and they owned the data center, and they owned the campus environment and maybe the wide area, but in the cloud, the network team could be removed from the equation. And then people learned lessons. I think the same thing happened with cybersecurity groups too. People learned lessons and realized, well, maybe we should let the network team have a seat at this table and the security team have a seat at this table. And so we're seeing network teams and security teams gradually reclaim some control, some sort of strategic role in cloud, especially as enterprises adopt hybrid multi-cloud architecture that drives a lot of complexity and risk. So yes, NetOps and SecOps taking more control, learning how to work with DevOps. This will be a theme of my research throughout all of 2026.
Great. Thank you, Shamus. Is the behavior of chat-oriented AI apps or prototypes showing up? And if so, is it driving new needs in terms of cloud network traffic flow tooling?
I did not ask anything about AI in this research. It was very focused on data, but not necessarily what's happening from an application perspective. I will say that previous research I published this year looked at how enterprises are adapting their networks to support AI traffic from the data center to the cloud and into the wide area. And from that perspective, enterprises, people who are network teams whose organizations are adopting AI today are recognizing that their network observability tools need improvement, need to evolve, need to do things like extract, increase the granularity of their network data collection, for instance, is a big one. They need to, for instance, they need to collect more network traffic data at higher intervals than they have in the past, specifically around flow. And also they need to collect more metrics from their infrastructure through things like SNMP, API calls, streaming network telemetry would be probably the biggest opportunity there. So what we're seeing is the presence of AI traffic in the cloud and the data center and elsewhere is driving up the need for more granular data collection from the network, which is going to drive up scale, drive up costs, and challenge current tooling. We'll continue to look at that throughout 2026.
Good to know. Thanks, Shamus. That answers all the questions that we received. So I will conclude today's event. I wanted to thank the audience for taking time out of your schedule to join us. As I mentioned at the start of the event, you will be receiving a follow-up email from EMA that will include the on-demand playback and a link to the report. And as Shamus mentioned, the sponsors should also have the reports as well, so be sure to check out their sites. Thanks again for joining us and enjoy the rest of your day.